Here we have question 9, and the key bit of information we need is this unit vector. Okay, so firstly, what is a unit vector? Well, if we look at A as a vector, okay, it's across 8 in the I direction and up 15 in the J direction. Okay, so we know that its magnitude is going to be this. Okay, which is 17. All right, well, for it to be a unit vector, we only want the magnitude to be 1. Okay, so magnitude of a unit vector is 1. Okay, so at the moment this has a magnitude of 17, we need it to be 1. Okay, so what we do is we divide this vector by 17. Okay, and that will force its magnitude to be 1. Okay, so this unit vector is going to be 1 over 17, lots of 8i plus 15j. Okay, that forces, when we find the magnitude of this, it's going to force it to have a magnitude of 1. Okay, so that's part I. Okay, I went into a lot of depth there, so then the rest of them are more simple. Part I, we need to find the angle the vector makes with I. Okay, so we've already got this diagram here, but we'll draw it again. Yeah, and we need to find the angle that the vector makes with I. Okay, so here's positive I. Okay, we need to find this angle. Okay, well, we're going across 8 and up 15, so using SOHCAHTOA, we need the tan of this angle, so F is opposite over adjacent. So then our x, if we put this in our calculator, tan inverse of 15 over 8, and that gives us 61.9 degrees above I. Okay, because we could also have 61.9 degrees below I. Okay, so we need to specify if it's above or below. Perfect. Now, part B, we've got 21i minus 7j. 21i minus 7j. Okay. Now, first, we need to find the unit vector. Okay, it's going in the same direction. All right, and now we know we just need to find the magnitude of b, okay, which is the square root of 24 squared plus 7 squared. Okay, put that on the calculator because I can't do that in my head. And we get 25. Okay, so then to find this unit vector, we just divide by 25. Perfect. Okay, now time to do our sketch. Okay, so it's 24 in the I direction, but it's down 7 here. Again, we need to remember that I is going this way. Okay, so we need to find this angle here, SOHCAHTOA again. So tan x, this x, is your opposite over your adjacent. Okay, so x is tan inverse of 7 over 24, which is 16.3 degrees. Okay, and now we specify that it's below I. Perfect. Okay, C, minus 9i plus 40j. Minus 9i plus 40j. Okay, this is our C. Okay, yet again, we find the magnitude of C, which is 41. So the unit vector is going to be 1 over 41, lots of negative 9 plus 40j. Perfect. Okay, next we need to find the angle that it makes. Okay, so here's our origin. Here is I. Okay, but it's going back 9 and it's going up 40. Okay, so we want to find the angle it makes with I, so we want to find this angle. Okay, so if we can see this triangle, we find this angle x, which is easier, then we can do 180, take away that. Okay, so tan of x is opposite over adjacent, so x is tan inverse of 40 divided by 9, which gives us 77.3 degrees. Okay, but we want the angle it makes with I, so we're going to do angle with I equals 180. Take away that, which is 103 degrees. And yet again, we label it above. Okay, because you could have 103 degrees going below. Now, part D, figure out what our D vector is. We have 3i minus 2j. 3i minus 2j. Okay, yet again, we need to find the magnitude of D, which is going to be the square root of 9 plus 4, which is square root of 13. Okay, so then our unit vector is 1 over root 13, 3i minus 2j. That's our unit vector. Okay, now the angle this makes, we're going 3 in the positive direction, 2 in the negative. Okay, so we want to find this angle because this direction is I. We want to find x. Tan x is opposite over adjacent. So then x is tan inverse of 2/3, which is 33.7 degrees, and we've got to specify below. Okay, and that's your answer for question 9.